Okay, so how do you solve SAT percentages questions these days? In this video, I'm going to cover everything you need to know about percentages on the SAT, all the different fancy techniques you can do with them, and how to solve any of these questions no matter how difficult. If you want to know why you should trust me, I've personally scored a 1550 on the SAT after starting with only a 1230. I've helped hundreds of students improve their scores already, and my goal is to make the channel you're watching right now the best online free SAT YouTube channel. So percentages, just to get the very basics out of the way, if you're not sure what this even means in the first place. What this basically is a fraction of a number. So fractions, in case you don't know what that is, it's like if you take a number like say 10 and you're only taking a piece of this. So 1 out of 2 multiplied by 10 would be equal to 5. Another way of writing this exact thing is saying 10 times 50%, or you could say 50% of 10, which would also be 5. So it's just another way of writing a fraction where you're taking a piece off of a number. So that's the very basics. But how do you actually use it on the SAT? A lot of students think this is really complicated, but honestly, it just comes down to this one thing: money. As do many things in life, if you just think to yourself, how could this work in terms of a sale? It becomes a lot clearer what you need to do. So for example, let's say you live in America or some other country that does tipping. In case you do not know what a tip is, basically, it's like when you go to a fancy restaurant, or just I guess really any restaurant actually, they expect you to not just pay for the meal, but also give an additional amount for the server who served you during that meal. So if you pay for a meal that costed like $100, you can't just pay the $100. Well, I guess you technically could, but people say you should not. And instead, what they say is that you must pay $100 plus also, let's say, maybe a 15% tip. So 15% of 100, pretty easy what that would be. That would just be equivalent to $15. So think to yourself for a second, how much money are you going to have to leave at the table at the restaurant? How much are you going to have to give them in total? Would it just be 15? No, because you have to pay the additional $100 for the meal as well. If you only pay 15, that's basically illegal because you're now stealing food. So you have to pay the full amount, which should actually be 115. That is the full amount. And that may seem super obvious and simple, but a lot of you guys are solving SAT questions as if you could just pay the $15 and leave the restaurant. It's kind of crazy, but it's actually true. Another way you can think about this in terms of money again is say you're trying to buy something from the store. Let's say it's also $100 just to keep it simple. And let's say they're giving a 10% discount on that thing. So thinking about again, 10% of 100, that would be equal to, you guessed it, $10. So how much does the thing actually cost now? Does it just cost $10? Well, assuming it's a 10% discount, no. It would be costing $100 minus $10, which would actually be $90. That is the full price tag for the thing now. Again, a lot of you guys are solving it as if you could just give them $10. So this should hopefully start making a lot more sense. And one thing that makes this so much easier is if you go here into Desmos, you can actually just type this very clearly. So like for this first example, what we really would be doing here is doing 115% of 100. And I can just type that directly into Desmos. 115% of 100 gets us 115. If you want to know where the 100 came from, it's because that's counting for the original price of the meal. 100% of 100 would just literally be 100. So all we're doing is adding 15% on top of it. That's how these percentages work. Likewise, for this one, what we're really doing here is doing 90% of 100, aka $90, because you have the full 100% and now you're just taking 10% off. So hopefully it should be making a lot more sense now. You're probably seeing how these percentages work. But one more thing that I really should mention before we get into the main stuff here is this thing with if you don't want to use the percentage in the first place. If I say something here like 115%, there is another way we could write this without even having to use the percent sign. And your algebra teacher probably has taught you this. If they haven't, they did a really bad job. But basically, if you take this percentage and just move the decimal point 2 places to the left, now you have 1.15. And that is also what you could multiply the number by to get to this thing. So if we see here, 115, I could just also do 1.15 times 100, and that gives me 115 as well. For the other one, same exact thing. If I did 90, I could just move the decimal point 2 places, and that gives us 0.9, so 90% of 100, same thing as 0.9 times 100. Either way works, but honestly, just to save time, I would suggest just doing it the 0.9 or 1.15 way because it's so much easier, so much simpler. But if you're getting into this for the very first time and you're really like a noob at these percentage questions, just go ahead and type it exactly like this. Makes it a lot easier, and this will help you actually visualize it a bit better. Okay, so for common situations, you can see your percentages. 15% of 200. If it says something like this, what it really is saying is 0.15 times 200, like we were shown before, and that would give us 30 for the answer. We can see here these both are the same exact thing. If we do 20% less than 50, this is like the discount example like I was giving before. So it's like you take 1 minus 0.2 for 20%, and that gives you 0.8, and then you multiply that by the amount. So it shows like this here if you put into Desmos. 25% more of 80, this is like the tip example. So what I would do here is do 1 plus 0.25, and that gives you 1.25 or 125%, multiply that by 80, and we get 100. So kind of like this over here. And then the final one that you may be a little bit more confused on, let's say you're trying to increase a number like 4 by 400%. Now this is a lot, but think about what each 100% is referring to. Really, it's just that full number again. So basically 4 of 4, and add that on top of 4. So 1 plus 4 would be equal to 5. 4 times 5 is equal to 20. So keep in mind, what we're really saying here is 500% of 4, because we're not just taking 4 and doing 400% of it, we're increasing 4 by 400%. It's like if we had 4 and we're trying to give a 400% tip on top of it. We wouldn't just give the 400%, we have to also include the original amount. So this is what all of percentages is going to be built on, this stuff, and then you can use Desmos or just write in the exact numbers. The other important thing that's going to come into this is that you can make equations using percentages as well. And this even works with the percentage thing in Desmos. So I could say here like 20% of P and say that must be equal to 100. And so now we can see here that 20% of 500 equals 100. If you did not know that you can do this, this is probably going to be another game changer, probably going to completely change how you're doing these percentage problems. Very easy, you can just write this equation. And if you're not familiar with what this sign is, this is just another way of writing the equal sign. It just makes it a bit easier so it shows on the screen instead of having to look at it on the graph. Like if I did it on the graph, I'd have to zoom all the way out, and then I only then would see, oh yeah, I'd have to make it X as well. So yeah, only then when I see it gets to 500. So this just makes it a lot easier. You don't have to do any of that process instead. So a lot of these problems are going to just consist of making equations using that. Let's start with this one. A jacket originally costs $40 and is on sale for 25% off the original price. So the discount example, what is the sale price of the jacket? So $40, and then what we're doing here is 25% discount. So what that really is saying here is 0.75. Again, according to the rules, 1 minus 0.25 would give us 0.75 for the total thing. 40 times 0.75, that gives us 30 for the answer, and that makes sense. It's important to mention with these problems that you definitely want to kind of just logic check your answers. Like if you got for this problem that it ended up being like $5, you can probably tell that seems just a little bit weird. Like if 25% off being $5, that's a bit more than just a 25% discount. That doesn't really make sense. So if you do notice that, always point that out and just keep in mind that you did something wrong earlier in the problem. Let's write another equation here. A computer sold 640 laptops in 2023. So let's just write 640 there. In 2024, the number of laptops sold increased by 12%. So increase here, something like the tip. Which of the following is closest to the number of laptops the store sold in 2024? So like we did with the other one, we just multiply this by 1.12, 716.8. And asking for the closest amount, so the closest to that would just be 720. Community Fitness Fair, 180 visitors filled out a survey. Of these visitors, 35% said jogging was their preferred activity. How many visitors prefer jogging? So again, I can just do 180 times 0.35, and that just gives me 63. If I want to prove this, I could also put 35% of 180. 63 again. A store sells a backpack for an original price. During a sale, the store reduces the original price by 20% and adds an 8% sales tax to the new reduced price. The customer pays $117.8 at the register. This is where it's going to get a bit more complicated. Let's say for the original price, we just say P for price. It says the store reduces it by 20%. What that really would be saying is 0.8, again, according to the stuff we said before, so times 0.8. Then we add an 8% sales tax, so kind of like if we did a tip here. So then we just multiply that number by 1.08. Now, it doesn't actually matter, but if you want to like be extra sure, you can just put parentheses around this, so it only takes this total amount for that. Okay, then the customer pays 172.8 at the register, so that I can just say equal to 172.8, and we see here the original price must be 200. For problems like this, it's often a good idea to check your answer just to absolutely make sure if you have the time to. So 200 times 0.8 times 1.08, yes, it gives me the right answer, 172.8. So 200 must definitely be right. A streaming service had 8,000 subscribers at the start of the year. In January, the number of subscribers increased by 12%. Then in February, 15% of subscribers canceled their subscriptions. What is the percent change? Well, for January, that would make sense to just be 1.12. It must be getting bigger, increasing, tip logic. February, though, 15% cancel. That means it's getting smaller, so discount logic, so 0.85 would instead be the thing there. So we just do 8,000 times 1.12 times 0.85. and then we get 7616. But then it's asking what is the overall percent change in the number of subscribers from the start to end in February. To do percent change, what you do is you take the new amount, so 7616, you subtract the old amount, so 8,000, and then you divide the entire thing by the old amount specifically. So minus this, that would mean a 4.8% decrease here because we moved a decimal place 2 places again. And since it's now a decimal, we have to go backwards on what we did before, so 2 to the right this time. So always remember that if it's ever asking percent change, it would be new minus old and then subtract the entire thing by the old. Always is going to be how it works. And this also just logically makes sense. We're basically saying here that we have this new amount, we're subtracting that old amount, so it's decreasing by some amount, and we're trying to see how big is that decrease over what we originally started with. How much of that would be losing, really? 6, in a student council election, Maya received 25% more votes than Juan. If together they received a total of 720 votes, how many votes did Maya receive? As these problems get more and more complicated, it gets more and more valuable to write down the information after you start the problem. If you're struggling on these really complex word problems involving percentages, chances are it might just be a matter of you missing certain details and then just writing the problem in the wrong way. So it helps to kind of just explain what's going on here to begin with. So we have Juan here, and then Maria received 25% more than Juan. So I guess we could basically say 1.25 Juan. And then if we add those together, it must equal 720 for the total amount of votes. Okay, so that's literally just what we have to put in here. So now you can see by writing that information, it made it so much easier. So, okay, so 320 is the amount that Juan received. Remember, it's asking how many votes did Maria receive. So we have to do 1.25 times J again, which would be 400 this time. That would make sense. Again, logic check this. Maria is the one who won the election, so it only makes sense for her to have more votes than the other person. So if you've been watching the video, paying attention, trying these problems for yourself, you probably are feeling pretty fine now with regular percentage problems. Now let's get a little bit more complicated and let's do some things that are still percentages, but a bit more difficult, I would just say. First thing that you will see, at least sometimes on the SAT, is this thing here when you have a solution and you're multiplying it, you're adding it to other solutions, and you're trying to figure out all this different information about it. The big thing you have to understand here is the difference between the solute and the solvent. You don't need to really know what those words mean, but here's what I'm trying to say with this. In this example, it says a container holds V liters of a 20% salt solution. What this is really saying is you have this tub of stuff, maybe, and out of that tub, you have 80% of stuff that's just like water, basically. That's just water in the thing. And then you have 20% of this, which is salt. I know salt is not black, but I'm just using that to show it on the white screen. So this is what's being really shown here. V is referring to this entire thing altogether. All of the stuff in here would be V. Point 2 is just referring to this amount of V that is salt. So if we were trying to write this in like percentage form, we could say here 0.2 times V, or we could say 20% of V. That is what it would be the salt in the thing. V is just the entire thing altogether. And so that simplifies the rest of the problem. So now we can actually just write stuff for what this equation is saying based on that information. So we start here with 0.2 times a V. Yeah, we can just go ahead and write that. And then it says the technician removes 10 liters of the solution and replaces it with 10 liters of a 5% salt solution. So the best way to approach it from this point on is you're just trying to figure out what you need to put in this equation to make it work. I know this isn't too scientific or too technical, or I'm not really giving you a full framework for this, but all these problems do work somewhat differently, so there's not any kind of one thing that I can just give you for what needs to be done in this problem. But for this, what we can do is we can have there be a fraction where basically we have the amount of salt on top and then the total amount of stuff at the bottom. So it says here removes 10 liters of solution. So we can write that by saying minus 10 times 0.2. If you're curious why it's times 0.2, because this is the amount of salt in solution, they're subtracting 10, but out of that 10, 0.2 of it will have the salt included. And then it says replaces it with 10 liters of a 5% solution. So plus 10 times 0.05 this time. And then finally, they add 5 liters of water. Would we add anything from that 5 liters of water? No, because what we're doing here is we're just showing the salt on top, not the water. We'll show that in the second part of this. So I can take all this and then I can divide it all by the total amount of things. So if I'm writing that example with the thing, this would be the total amount in here, not just the salt this time. So I can say V, so that would be the original total amount, then subtracting 10, because 10 liters removed, and then adding 10 liters added, and then this is where we add the water, 5 liters of water. So if you were paying attention, if you're following along with me, you can probably see what's going on here. We have the salt at the top, all these percentages, and then we have the total amount at the bottom. We can then equal this to 0.15. because 0.15, what this is basically saying is 0.15 divided by 1, which would be 0.15, the salt, out of 1 liter. I can then just tilde it, and now we get 45 for the amount of V. So when we started out, we had 45 liters in that tank, and then we added all this stuff to it. If you want another example of this, I can show here. This is something I had Claude make. This is the full description of everything that I'm adding here. It does have the water on top, but it just has 0 to it, so it would cancel out and just be nothing for that, but that's why there's that there. Okay, let's look at this one now. A container holds a liquid mixture that has 40% vinegar, 60% water. 20 milliliters are removed and replaced with 20 milliliters of water, and the resulting is 25% vinegar. So basically what we're saying up here is that we have a mixture that is 0.4 of vinegar. So I can just say 0.4, let me say 0.4 times M for mixture. And then it says 20 milliliters of only vinegar are removed. What we can just do for that is subtract 20. Now that may not look right, but think about what we're saying here. This is the amount of vinegar in the original thing because we don't know how much M is. And then we're just taking away some vinegar. So this all would balance out as typical. And then it says add 20 milliliters of water. So that would not go in the top because that is just water, that is no vinegar at all. So we would just divide this whole thing now by M, which would be the original amount. And it actually would just be M because it says 20 milliliters are removed and replaced with 20 milliliters of water. So the total amount of stuff never actually does change. It's only the stuff at the top that changes. So then we set that equal to 0.25. And now you have 133 1/3 for the mixture amount. So C would be the answer for this one. Always just remember with these, whether you're dealing with the solute or the solvent. So 0.4 times M, that is the amount of vinegar. M would just be the total stuff altogether. And so that's how all of this is going to work every single time you're approaching a problem like this. But besides that is literally just writing equations based off of the stuff that is given here, so not too much more complicated. Now, sometimes you can have a problem where it's worthwhile to just write your own random number for what you're dealing with. So we have here 62% of the attendees at a festival visited the food court. Of those, 45% bought a beverage, and of the buyers buying from the food court, 35% choose a smoothie. And then it asks what percentage of people did not even choose a smoothie at the food court. So someone who's low IQ might literally just like write in here like 0.62 and then use a variable for that thing. But the thing you might realize is that it doesn't really matter what number we choose for the total amount of attendees. We could choose 67, we could choose 100. It literally doesn't even matter at all. We're still going to get the same answer because we're only dealing with percentages here. We're not dealing with any absolute amount of people. It would be a different kind of story if it asks here like what are the amount of people who did not have a smoothie, and it gives us like 100 or 200 or 300. But if we had a question like that, we would have much more information given anyways, so it would not be like this. So let me just choose a number like 100 to keep it easy. So let's say we have 100 people to begin with. 62% of them visit the food court, so 100 times 0.62. Then 45% of them buy a beverage, so times 0.45. And then 35% of them get the smoothie. So we have 9.765. Keep in mind, I know this looks a little bit weird because you can't have 0.765 of a person, but it would make sense because like say this number was instead like 1,000 or like, oh, I guess maybe like this amount. Now we just have 9,765 people. So it just is a smaller way of writing that. So basically this, and then says what is the percentage of people who did not choose a smoothie at the food court. So I can basically say 9.765 divided by 100. That gives us that. And if we move the decimal point 2 places, we get here 9.765. So I can just say here 100 minus 9.765. That gives us 90.235. And so we're basically dealing 90.235 out of 100, which would be this, which is basically the same as this answer here. Did not even matter at all. If I want to prove to you that it literally doesn't matter what number you choose, I can just replace this with a different number. Let's say it is 67, and then we have this number instead, and then I do 67 minus this, which would just be 60.45745, and then I do 60.45745, and then divide that whole thing by 67. We get the same exact thing, 0.90235. So doesn't even matter at all. It could be any number you want. So that's why you can just do this. Okay, one thing I just have to address real quick is if it looks something like this. We have here the volume of container A is 250% of that of B. Volume of container A is also 0.04% of volume of container C. And C is P% of container B. All this kind of random information in this problem. We have like 3 different containers, A, B, and C, and now they're giving us different information about their relationship. Like A is 250% of B, B is whatever of C, like all this other stuff. When you have like multiple different variables here and they're saying each one is a percentage of another one, you should go to the desmos regression way of solving a problem like this. If you do not know what desmos regression is, I would heavily advise watching my full video on this that I have on the channel. But let me just give you a quick overview. what we would do here is let's write out each equation we have, and then I'm going to write out all of them in the form left, left, left for each of the left sides, and then tilde, right, right, right. That is basically what I'm about to do here, so you're not confused. So A is 250% of B, so I can just say A equals 250% of B. Then it says A is 0.04% of C, so I can write that as well. And then it says the volume of C is P% of the volume of B. So these are the three equations. Now let me write it in that form I just said. So keep in mind, again, I'm taking the left side of each, and then I'm going to set those equal to the right side of each. So the left side would be A, and C for each of these, and then tilde for equal sign again, and then the right side. So 250% of B, 0.04% of C, and then finally P% of B. We have here now all of these different numbers, and it says what is the value of P over 100? That would just literally be 6250. So therefore 6250 is the answer. The way I knew that I had to do this problem like this is because we had different things and each one was a different percentage of the other one. That is the way you know to do a problem like this way. You could also just know by the fact that you have 3 or more different variables. We have A, B, C, and P here. So a lot of different variables for this problem. When you have all those different variables, the easiest way you're going to do it is just with a regression like this. Again, though, watch my video if this does not make any sense for you. One more kind of weird problem just to end us off for today. So a debate team had some juniors and seniors. Then 30 juniors and 20 seniors joined the team. At that point, juniors made up 45% of the team. So a debate team initially had some number of juniors and seniors, and then it says some joined and some left, and then all this other information. It's asking us here what percentage of the original team was juniors. So the way to think about this problem is like it pretty much is the same as those concentration problems I had above, like with the salt and with the vinegar, all those different things. It's just with people instead of, salt and vinegar. The way we can think about writing this is if we're trying to find the amount of juniors, it has to be juniors divided by juniors plus seniors. This would be the total amount of people, and this would just be the juniors that we'd be trying to find. So for the first one here, we can say J divided by J plus S, and then it says 30 juniors and 20 seniors join the team. So I can say plus 30 because 30 juniors at the top. And then here I would have to say plus 20 and also plus 30 because this is the total amount of people who are now in there. And I can say that is equal to 0.45. All right. We do have like 0.35 of a person, but we'll settle that in a second. First, let me write the second one here. So it says here 10 juniors and 5 seniors left the team now. So I can say minus 10 up here and then minus 10 and minus 5 down here. And so now it says it must be 0.44% of the team. So the thing is, this may look fine to you, but it actually is not fine because when you're writing it with the regression here and you have multiple different equations, you have to put them all together in one thing like we did for the other problem. So instead of this, we'd have to put them again in brackets and then put the left sides of both and also the right sides of both. Now we get some more reasonable answers like 123 juniors and 167 seniors. It asks us what percent of the team was originally made up of juniors. So we can just say now J divided by J plus S. That'd be 0.42. So basically 42% of them would be juniors. So hopefully you can see now that all these problems just come down to taking the information that they give you and writing it out now that you know the actual way percentages work. If you have questions about literally any of these problems or anything else involving percentages, drop it below. I will answer every single comment on all of these videos. If you want me to help you improve your score at least 100 points before your next test, check out Mission 1400 Plus with the link in the description below. You'll be taken to a page like this, and the great thing about this community is what you get when you join is actual support from me to help you improve your score. I respond to every single post in here at the end of every single day, plus you have a full roadmap over here on every single individual item you need to do to improve your score. This will take you through the full math course and the full reading and writing course, and it's fully gamified as well, so it's fun throughout the entire time. Probably the coolest part about it, though, is you actually earn credits for studying each day, like all of these students have here, and then you can use those credits on a bunch of really cool rewards as well, like one-on-one tutoring with me and the chance for me to review your practice test. If you're at all interested, check the link in the description below. You can start a free trial, and then after that, it literally costs as much as $4 per day. If $4 per day is worth it for you to improve your SAT score, check it out right now with the link in the description. Good luck on the SAT, and make sure to always stay Gucci.